Welcome to Math Elevations and the CRA method of learning math.
Hi, I'm Isabella. I want to introduce you to Math Elevations. Brought to you by North Point Horizons.
First step to exploring math is through a hands-on approach.
Hi Isabella, you ready to learn about fractions?
Yes.
Okay. Honey, do you know what using a whole is?
No.
Well, a whole can be anything. Do you know what a whole pizza is?
Yes.
And do you know what a whole person is?
Yes.
Yeah, and a whole house?
Yes.
Now, let me ask you something. In a whole house, what would the kitchen
Part
be?
of the house.
Right, so would a bedroom be?
A part of the house.
Very good. So it's anything can be a whole and anything can be a part,
Yes.
right? So what we're going to talk about today is how this particular rod
Okay.
is a whole, okay? Now I want you to find another color rod that makes two equal parts to that whole.
Okay.
Very good. So what is the yellow?
It's a part of the orange.
And how many did you need to make?
Two.
Two, okay. Well, let's take the blue rod. Is the blue rod the same as the orange?
No.
But it's still a whole, right?
Yes.
How many parts does that take to make a whole?
Three greens.
Very good.
It takes 3 green rods to do it.
Okay. So how many? So tell me something about the parts. What do they have to be?
3 green rods.
And they're three equal parts, right?
Yes.
Okay. Let's take that green rod. How do we find out how many parts that can be?
We put the white ones on.
Okay. And how many parts for the green rod to be a whole?
3.
Very
3
good.
whites.
So if this blue hole
Equals 3 of those.
equals 3 of these, and then we take one of the green ones and find out how many parts it needs 3, right?
Yes.
So how many whites would it take to make the blue?
9.
Very good. You want to show me?
Yes.
Okay, how many white parts did it take?
9.
9. Okay, how many green parts? Put the green parts next to it.
It would take 3 of the 3.
So when a green rod is a whole, how many parts does it take?
3.
And how many parts does the blue? 3 green,
3 greens and 9.
9 parts.
The second step to understanding math is translating three-dimensional to two-dimensional with drawings.
Isabella, you ready to go on to the next step?
Yes.
Okay, to get started, I want to show you how each one of these squares on the grid paper is equal to the white.
Okay.
All right? So show me how many white squares here you'll need to make the blue hole.
Okay.
And you can count out.
1, 2, 3,
And then,
8, 9.
very good. Give it all a shade. Just go up and down and shade it like that, real lightly. Just to show that it's a hole.
Okay.
Very good. All right. Now, when we were playing with the blocks before, how many did we decide of the green?
3.
How many squares here does it take to make one of those?
3.
Very good. Okay, so you can show me the 3 squares made up of 3 blocks. You can count. 1, 2, 3. Very good. All right. Now, that means we have 3.
Of these.
Very. Now I need you to shade each one separately. Okay? each of the three separately. Very good. You even gave it a darker color. I'm impressed. All right. Now, how many did we decide? How many white cubes, which are equal to the white square, would it take to make the green?
3.
Okay. So, can you show if there are 3 of these, and it takes 3 for each one of these? How many squares will you need?
9.
Very good. So instead, you don't have to shade them all in. Why don't you just outline each square, okay, that you need.
Two, 3, 8, 9.
So that 9
Yeah.
of your drawing equals a whole
And
3 of those parts. Very good. Okay, Isabella, we're ready now to learn about fractions. But this time we're going to use a whole part that's the brown bar, okay? I want you to tell me how many of these white squares makes up that brown one. How can you tell that? If you lay this right here,
it would be 8.
8. Very good. So can you draw the whole of this brown one? Okay.
The whole.
You can count it
1,
out.
2, 3, 4, 5, 6, 7, 8.
Very good. I want you to shade in 3 of those squares. Okay. All right. Let's go back. We talked about that this was a whole, right? Another name for a whole is the denominator.
Yes.
Okay? And in fractions, there's a line, and then there's where you put the whole number or the denominator. All right? And that would be, and how many did we say there were? 8. So we're going to put in,
8 right here.
we're going to put the number 8. Okay?
Right there.
Right.
And then 3 will go on top of it.
Oh, 3. Okay, because there were, how many parts did you color in?
3.
Okay, put 3 on the top, and that's called the numerator.
Yes.
And that's what's called a fraction.
The third step to comprehending math is understanding the math in symbolic form.
All right, Isabella, is this the only way you can show how this whole is?
No.
Well, let me ask you, how many squares were there again? 8, very good. What is the half of that?
4.
Very good. So how many sets of 4 makes that 8?
2.
So could you show me how you can make 2 sets of 4 a different way from this?
Okay.
Okay. All right, tell me about that. How is that the same as this whole?
Because it has 4, and this has 4, and then this has 4, this has 4.
Very good. Can you show me one other way that you can do it? Okay.
Same way, it's just opposite.
Okay,
Of this.
very good. Shade 3 of these squares and then we'll talk about it.
Okay.
Just 3 of the squares. All right. So what would the fraction look like?
It would be 3/8.
It would be the same as this.
Yeah, it's the same as this.
Because this is the same whole,
Yes.
and those are the 3 parts. Is that correct?
Yes. it's
Very
correct.
good.